Hi, this is Aaron Holmberg at Corvallis Middle School, 5th grade. And this short video here is about reviewing some terms in 5th grade math that are really from 3rd and 4th grade, but we kind of unify them this year. Factors, dimensions, arrays, and areas. Students need to know those terms in 5th grade and be able to use them kind of interchangeably, and when they hear them, know what to do with them in their work. So here I've got 3 representations that are all meant to be the same thing. For all practical purposes in 5th grade, whether we talk about array models or area models, we're going to be talking about the same thing. That these are basically almost the same idea, even though there are slight differences between the two. Okay, so here we have an arrangement of objects. It's almost the word array, arrangement. An array or an area are going to be two-dimensional and flat, where an arrangement might be three-dimensional like this. So we have 20 objects there. You might have seen that quickly because you could divide it up as 4 rows of 5. Like that is how it could be arranged, or you could also make it be 5 columns of 4, and it would still be 20, and when it's unified, then of course it's 20. So the word factors are just numbers used to multiply. So if we said they're whole numbers used to multiply. So a factor times a factor is a product. And for that reason, we're just looking at factor times a factor is a product, and that's what we have here. 4 by 5 is 20. Okay, dimensions are when you move from sort of an arrangement, like a three-dimensional arrangement, to a two-dimensional representation of it. So dimensions are going to be side lengths. So this would be here. Factors are, not good enough. Factors are whole numbers used to multiply. Okay, good simple definition. Dimensions are going to be side lengths of an area or an array. So I could come over here and say the dimensions of this arrangement or this array are 4 by 5 because those are the side lengths there. And if I come to a picture like this in the middle, I can do the same thing. I can say that it's 4 by 5. In class, of course, we recognize the commutative property just means that you can turn the array the different direction, and the order of the factors, so the order of the two dimensions may change, but the area is still going to be the same 20 no matter what direction it is sitting. So that's kind of what the commutative property means. Order doesn't matter to products. And then over here on this end, basically we expect students to leave making grids behind in 5th grade. That if they're going to draw something and talk about it being an array or an area model, they would just do something like this to represent that they know that this is a picture of 4 by 5. And we emphasize that an array model or an area model is a picture of multiplication. So that's a picture of multiplication there. Of course, the next big thing that 5th graders are expected to be able to do is that if they are given a number like 20, that they can recognize that 4 and 5 are not the only two factors, that you could take this and regroup it in a number of different ways, like 2 by 10, like 1 by 20, and that those are all factors of 20, and that they should be able to list all of the factors of a given number in various ordered ways, like 1, 2, 4, 5, 10, and 20, or perhaps in factor pairs, which would be 1 times 20, 2 times 10, and 4 times 5. Furthermore, we'd want students to know things like 3 times 7 proves that those are not, that neither 3 nor 7 is a factor of 21. So that's just a brief reminder and refresher on what factors, dimensions, and arrays are.